Advanced Functions, Lesson 6. In this lesson, we are going to use factor theorem and factor p at x equals 2x3 plus 5x2 minus x minus 6. Let's start with a rational zero theorem. If p at x equals 0 has any rational root, that root must be one of these numbers, plus minus 1, plus minus 2, plus minus 3, plus minus 6. The numerator is 6 and the denominator is 1. Plus minus 1 over 2, plus minus 2 over 2, which is 1, plus minus 3 over 2, plus minus 6 over 2, which is plus minus 3. So these are possible rational zeros of p at x. If we plug in 1 in to p at x, we have 0. This means x minus 1 is a linear factor of p at x. Now we divide p at x by x minus 1. I use synthetic division, Horner's method. 1 times 2 is 2 plus 5, 7. 1 times 7 is 7 minus 1, 6. And 1 times 6 is 6 minus 6, 0. The remainder is 0 as we expected. Therefore, p at x can be written as x minus 1 times 2x2 plus 7x plus 6. Let's check if we can factor 2x2 plus 7x plus 6. 2x2 plus 7x plus 6 is a quadratic trinomial. We are looking for two numbers that add up to 7, and the product is 12. Obviously 3 and 4. There are different methods to factor this. I break down the middle term using 3 and 4. 2x2 plus 3x plus 4x plus 6. We group them. X times 2x plus 3, first group, and 2 times 2x plus 3, the second group. If we factor, we have 2x3 times x plus 2. The common term is 2x3 plus 2. Therefore, p at x is x minus 1 times x plus 2 times 2x plus 3. This is the method that we use to factor a polynomial using factor theorem. To solve an equation with the degree 3, 4, 5, what we do, we use the same method. Let's solve one equation, x3 minus 3x plus 2 equals 0 by factoring. I call x3 minus 3x plus 2 p at x. P at 1 is 0. Therefore, x minus 1 is a factor of p at x. If I divide x3 minus 3x plus 2 by x minus 1, I have x2. x3 minus x2. If I times x2 by x minus 1, x2 minus 3x plus 2. x2 divided by x is x. x2 minus x. If we subtract, we have minus 2x plus 2. Minus 2 minus 2x plus 2, 0. Therefore, the equation can be written as x minus 1 times x2 plus x minus 2 equals 0. x2 plus x minus 2 is a quadratic trinomial that can be factored as x minus 1 times x plus 2. Sum is 1, product is negative 2. Therefore, our equation is x minus 1 to the power of 2 times x plus 2 equals 0. It has a double root, a root with multiplicity of 2 at 1, and a simple root at negative 2. So far in the course, we learned, using some examples, how to divide a polynomial with another polynomial, division. Two methods, long division and synthetic division. Division statement, which says if you divide a by d and get q as quotient and r as divisor, a is q times d plus r. The degree of r is always less or less than the degree of q. The degree of d, the divisor. The degree of q is the degree of a minus the degree of d. We learned the remainder theorem, if we divide P at x by x minus a, the remainder is P at a. If P at a is 0, then x minus a is a linear factor of P at x, and vice versa. We ran the rational zero theorem, which states if an equation has a rational root, the numerator of the root divides the constant term in the polynomial, and the denominator of the root divides the leading coefficient of the polynomial. And we'll put all of this together and factored a polynomial. Thank you.